right, so what do you need to see, guys? Yep, 10, yep. All right, so this was the bonus, or challenge, I guess we could say. So it says to write the equation of the ellipse with the following conditions. Vertices at 3, 0, and negative 3, 0. So what that tells us then is that these are 2 points on our circle. Okay, 3, 0, negative 3, 0. 2, and then about 7 and 1/3 is another point on the ellipse. So it looks something like that. All right. So what I know about this is that the center is going to have to be at 0, 0 because it has to be in between those two. So I know I've got x squared plus y squared has to equal 1 because it's an ellipse. Under the x's, I know I went out 3 units, so I know this has to be 9. So the question is, what is that? What's that answer right there? Okay. So I'm just going to call that, I'll call it x. Nah, I don't want to call it x because I have the x there. Let's call it b squared. All right, because that's what normally would be there, either b squared or a squared. So what I can do now is I know that the ellipse has to contain this point, so I'm going to have to plug this point in. So 2 squared is 4 over 9, plus I have to plug that point in here. So 22 squared is, what, 484? So it's going to be 484 over 9 all over b squared has to equal 1. Now, I don't really like having this complex fraction here. So to get rid of it, I can multiply the top by 9 and the bottom by 9, and then these cancel. So now I've got 4/9 plus 484 over 9b squared equals 1. So to solve this, I can multiply through by my common denominator of 9b squared. When I do that, the 9's cancel, so I get 4b squared, plus the 9b squareds cancel, I get 484. 1 times 9b squared is just 9b squared. So I'm going to get 5b squared equals 484. So therefore, that b squared has to be 484 over 5. And that's what I wanted to find, is what is this value here? Well, b squared is 484 over 5. So now my equation is going to be x squared over 9 plus y squared over 484 over 5 equals 1. But I don't want to really have a complex fraction here, so what can I do with this part? I can just multiply the top and the bottom by 5. So I multiply the top by 5 and the bottom by 5. And so my best equation, kind of out of room here, put it right here, x squared over 9 plus y squared, 5y squared over 484 equals 1. And that would be the equation that's going to have those vertices and pass through that point. Anybody else have questions, or did anybody do it a different way, an easier way? Okay. What else do you need help with? Anything else? All right. Let's go right into the notes, and then we'll roll the dice for the homework, okay? So get out your notes packet. Okay, so today we're going to talk about these things called hyperbolas. So for hyperbolas, they're going to look quite a bit different from anything else that we have done. Hyperbolas are going to open either left and right or up and down. So let me just show you some examples of the way hyperbolas can look. Hyperbolas can look like this. That's one hyperbola. A lot of times people think, oh, that's just 2 parabolas. No, this is called a hyperbola when you have one up and one down. This is going to happen whenever y comes first. A hyperbola can also look like this. Again, this is just one hyperbola. So this is when it opens to the left and to the right. So looking at our notes here, the definition of a hyperbola is the set of all points P in a plane such that the absolute value of the difference of the distances from P to the foci is constant. Not a big deal that you understand the definition. It's more important that you understand how to graph it. But that's where it comes from. The fixed points right there, those are called the foci. We've already talked about foci with ellipses. So here's our standard graphing form of a hyperbola. Notice we still have x minus h squared and y minus k squared. But what do you notice is different about the value in between them, Drew? Right, it's subtraction instead of addition. The other thing you should notice is that in this one, x can come first. If x comes first, it's going to open this way, side to side. But if y comes first, it's going to open this way. This point, these points here and here, those are called our vertices. These points here and here, those are called our vertices. Notice that a squared always comes first. That's not a big deal, but if x comes first, left and right, y comes first, up and down. And the center is going to be HK. All right, so let's look at some examples now. These are some parts of the hyperbola that you have to know. So first of all, the transverse axis. This contains only the vertices. It contains the foci, and it has a length of 2a. The conjugate axis, this contains no vertices, and this has a length of 2b. The distance of A and B are used to form a rectangle that we use to help us with our graphing. The foci is always going to be c units from the center. To find c, we have to use a squared plus b squared equals c squared. The foci are always on the transverse axis. The asymptotes are going to be other things that we're going to graph. These asymptotes are going to go through the rectangle like this and this. All right, let me just start graphing, and I think it'll all make sense to you. To graph, we first of all have to get this equal to 1. So I'm going to divide by 36. So I'm going to have x squared over 9 minus y squared over 4 equals 1. We'll go ahead and fill this in here. So the first thing we want to identify is our center. Our center is going to be at 0, 0 because there's no HK. So here's my center. In the x direction, we have to go out 3 units. In the y direction, we have to go out 2 units. So far, it's just like an ellipse, isn't it? Okay. If that had been a plus, I would just create my ellipse and be finished, but it's not. It's a minus. So when it's subtraction, we're going to create this rectangle here. The next thing we do is we draw the asymptotes. The asymptotes are going to come, they're going to go from corner to corner and through the center. Kind of come through just like this. Okay. These are our guidelines. We never go inside the rectangle, and we never cross these asymptotes. X comes first, so it's going to have to go like this. So the next thing we're going to jot down are our vertices. Our vertices are always on this transverse axis, and we went out 3 units, so it's going to be 3, 0, negative 3, 0. These things here, these are called conjugate axis endpoints. On your worksheet, you don't even have to find these, but I'll just show you how to find them. That's going to be these 2 points, so those were just 0, 2, and 0, negative 2. The next thing we have to find are the foci. So I have to do a squared, which is going to be 9, plus b squared, which is 4, equals c squared. 13 is c squared, take the square root. c equals radical 13. Do you think we go left and right radical 13 or up and down radical 13? Left and right is right, Natalia. And that's because they have to lie inside the hyperbola. So radical 13 is about 3.5. So our foci then are at radical 13, 0, and negative radical 13, 0. Now the asymptotes, those are these things right here. We have to find the equations of those lines. So this line right here, I want to know its slope. So I can see that I go up 2 and over 3. I also want to know the slope of this asymptote. I can see that I go down 2 and over 3. So the slopes that I'm going to be using are 2/3 and negative 2/3. The easiest point to use that it's going to pass through is the center, and the center is 0, 0. So now I have to use my point slope formula up here. So I'm going to have to do y minus y sub 1, it passed through the center, 0, 0. So y minus 0 equals 2/3 times x minus 0. So y equals 2/3 x is one of the asymptotes. For the other one, y minus 0 has to equal negative 2/3 times x minus 0. So y has to equal negative 2/3 x. And so those are going to be the two asymptotes equations. Questions on that? All right, let's go down to this one. I want you to think about what the center is, and you have to remember that it has to go x, y. Think about what the center would be. Any ideas on the center? Dominic? Good. Negative 1, 2 is correct. Guys, this is the most commonly missed kind of question, because can you see how people just glance at this and put 2, negative 1? That's not right. You have to do x, y, so it's negative 1, 2. All right, so I'm going to go ahead and put in my axes. Negative 1, 2. Caroline, what am I going to do in the y direction? How far did we go in the y direction? 3 in the y direction. And those are always going to be my vertices. That's going to be the direction that the hyperbola opens. So from this center, the x doesn't change, but from 2 I had to go up 3 to 5. The x doesn't change, and I had to go down 3 to negative 1. Those are the vertices. The next thing we have to look at is in the x direction. Maya, how far am I going to go out in the x direction? 4. All right, so we're going to go out 4. Those are called the conjugate axis endpoints. You're not even going to have to state those in your worksheet, so I won't even state them now either. Create your box, your rectangle. Go from corner to corner through the center. Corner to corner through the center. Okay, and now we're going to find our foci. To find our foci, we have to do a squared plus b squared equals c squared. So c is 5. Should we go up and down 5 or left and right 5? Jake? Up and down 5. All right. So now I'm going to go ahead and graph. So I start from my vertices. Don't go inside the rectangle. Don't go outside of the asymptotes. So it's going to look like that. The foci, the x stayed the same. I went up 5. The x stayed the same. I went down 5. Lastly, I have to find the equations of the asymptotes. So I have to think, what did I do? What's the slope? we went up 3 over 1, 2, 3, 4, 5. We went up, or 4 rather. 1, 2, 3, 4. So our slope then is going to be 3/4 and -3/4. Our center is -1, 2, so I'm going to have to do y minus y sub 1 equals m times x minus x sub 1. So one of them is going to be y equals 3/4 x plus 2 3/4. It's one of our asymptotes. To find the other asymptote, I have to use the same point, but the slope of -3/4. So this is going to be y equals -3/4 plus 1 1/4, 3/4 x. Don't forget the x. Okay, questions? All right, let's go back here 1 minute. Let's just say that we wanted to graph this. It's also good to be able to put these into graphing form. So to get it into graphing form, you have to be able to solve it for y. So let's say I wanted to check this. I'm taking a quiz. I'm not sure if I did it right. So I've got 4x squared minus 9y squared equals 36. Well, I would subtract 4x squared. Negative 9y squared equals 36 minus 4x squared. I'd have to divide by -9. Come up here. So y is going to equal, I've got 36. I got to divide that by -9. And then I have to divide that by -9. So now I'm going to have y squared equals -4 plus 4/9 x squared. How would I now solve this for y? If it's y squared, I'd have to take what? Square root. And what do I have to put out in front if I take the square root? So this would be plus or minus -4 plus 4/9 x squared. So watch, now I can actually graph this because now I have it in a graphing form. So I have to do the square root, -4 plus 4/9 x squared. And I have to do negative the square root of -4 plus 4/9 x squared. Zoom 6. And see how that's our graph right there? Looks a little bit off. Oh, gotcha. Why does that look weird? So it doesn't graph the rectangles or the asymptotes because that's just like our guideline, and the calculator doesn't need that guideline, but you can see how that does work out. Okay? All right, so what do we do if we start off with one that's in this already multiplied out form and we want to get it into graphing form? Would you know what to do? Just complete the square, right? Just like we did with ellipses. So I'm going to have 25x squared minus 50x minus 4y squared plus 24y. Take the 111 over, so equals 111. Now before you can complete the square, you have to get rid of this 25. So you factor out the 25, you have x squared minus 2x. Factor out the -4, you have y squared minus, right here guys, let me show you this. This is where everybody loses a point. 24y, you have to factor out the -4. So what's this going to become? Not plus 4y, but minus 4y. Do you see why? Yeah, that's what I meant. Gosh, I was so hung up on the positive negative that I didn't divide it right. Yeah, so it's positive 24y divided by -4, so that's why it becomes minus 6y. Okay? So I take half of this and square, I add 1, but what did I really add? 25. I take half of 6 is -3, square it is 9. But I really didn't just add on 9, what did we do? Subtracted 36, right? Because we had to do 9 times -4, which is -36. All right, so now we've got it. We've got 25 times x minus 1 squared minus 4 times y minus 3 squared equals, and all of this is just 100, divide by 100. So we're going to have x minus 1 squared over 4 minus y minus 3 squared over 25 equals 1. And we're not going to find everything, but we'll just graph it real quick. So to graph it, my center is going to be at 1, 3. I go out 2 in the x direction. I go out 5 in the y direction. I create that rectangle. Make that box. And this is going to open in the x direction. Okay, questions? All right, you guys do the last one. I want you to put that into graphing form on your own. You got it? All right, guys, so here's what you should have ended up with. X minus 1 quantity squared over 25 minus, and make sure you have, little mistake in there. Anybody see what the, do you see it? Yep. So right here, this needs to be a plus. This is the thing that I was saying that people always forget. And the reason for that is because we're factoring a negative out of there, so it becomes a plus. So this is now a plus, and this would be a plus. Okay? Everybody get it? All right. Nice job, guys. So your homework is that worksheet, and we'll go ahead and roll the dice too.